Hello, I'm Svetlana Boriskina. I work in the Department of Mechanical Engineering at MIT, and today I'm happy to talk to you about the technology under development in my group, and that is technology focusing on high performance and sustainable polyethylene fabrics. So this type of textile is monomaterial, meaning only one material is used without being blended or mixed with anything else. It provides passive cooling functionality to the wearer. It is stain resistant, and it is a sustainable technology. So who can benefit from this type of technology? Well, obviously all of us can, because all of us wear clothes. But we identified a couple of potential customers that can benefit more than others. And one type of customers are mothers of children who have to wash, or fathers if they have to wash a lot of clothes. And we know that children's clothes need a lot of washing. They can benefit from a passive cooling functionality because children cannot complain often. They cannot speak yet. And this type of clothes can really benefit from detergent-free washing to avoid any kind of skin conditions. And not surprisingly, this is a large global market for this type of textiles. Another type of application that our technology can help with is athletic apparel. It's also a large global market, and needs are very similar. So need for passive cooling to increase performance, especially in adverse weather conditions. Need for fast drying. A challenge to keep clean when you're working out in the field. And odor and microbial resistance are obvious performance requirements for this type of application. So our technology helps to address all these challenges. And also it helps to address a broad impact problem, which is the textile industry in general, which is a global polluter, and it causes water shortages, release of toxic chemicals, release of microplastics in the environment. And if a technology can minimize all this or avoid completely all of these consequences, it's an additional plus. So how our technology works, we start with a common plastic, polyethylene, which can come in the virgin variety from petrochemicals, recycled variety, or it can be bio-derived from sugarcane. We spin this plastic in the form of a fiber and yarn. We color those fibers without using any water in a dry fashion. And then we weave or knit them into fabrics and garments that can be recycled multiple times because we only use one material to achieve performance. What makes this fabric unique and why people could benefit from these properties? It's because we engineered the fabric on multiple scales to change the properties of polyethylene, which is normally hydrophobic, meaning it rejects water. That would make it very uncomfortable on the skin because it traps perspiration under the fabric. But we changed the properties of the fiber surface to make them hydrophilic, and that allows for moisture wicking and quick evaporation. We also engineered the properties of the fabrics to make them tunable for the thermal radiation transport, so radiation heat from the human body. This is a natural cooling mechanism that is unfortunately impeded by conventional textiles, which absorb this radiative body heat. So our fabric actually helps to release this body heat efficiently, providing passive cooling functionality. We also explored the natural inertness and stain resistance of polyethylene, which is illustrated in this figure. Even if you try to stain it on purpose and then rinse with cold water without any detergent, it emerges completely clean. Not the same with other materials we tested. And that obviously helps to save water, energy, and avoid the use of detergent. And again, people with skin conditions can really benefit from this type of inert fabric that does not require use of detergent, because that can minimize any sort of skin irritation. This technology is sustainable in the sense that it generates a very small environmental footprint in the fabrication. And on the left, I show a simple example of just water usage for a t-shirt from our material and t-shirt made of conventional material cotton. So you can see a huge difference. And on the right, we show an overall environmental footprint that needs to be as small as possible for a fabric to not leave an impact on the world. And you can see that our fabrics actually have the smallest environmental footprint. And we also hope that this technology can help to eliminate a vast amount of accumulated plastic waste that is currently not used because it's not economically viable. So applications we look at include baby apparel, athletic apparel, as I already mentioned, but also we are looking at more advanced applications in military textiles and space and planetary exploration. And we work with a few industrial partners in this endeavor. And finally, I would like to thank the team of students and postdocs who contributed to this project over the years, and all the sponsors who support our research. And we welcome new members to this team. So if you would like to work with us, either on a research collaboration or in supporting our research or commercialization efforts, please reach out to me at email or website that are indicated at the bottom of this slide. Thank you very much. It was a pleasure talking to you.